Hello, this is my English speaking practice, but I thought I started to broadcast, but I couldn't. And I realized right now, so I restarted broadcasting. And yeah, it's been a while. And I changed my topics I'm gonna speak, I'm gonna talk about. Because I needed to study about technology, so yeah, for my work. So today I'm gonna study about um, virtualization. Virtualization, yeah, which is a technology about um, to make it possible to run guest OS. To run guest OS, and the main goal is to understand three types of virtualization: PV, HVM, and PV, HVM. But I don't know what they are, so I'm start with one by one, and the first topic is different between emulation and virtualization. Yeah, I was talking about this and while writing down these memos. Mm. Yeah, but this is main goal of this video is to practice speaking in English. So yeah, so you don't expect my video is interesting. I just study in English. Okay, so let's start with topic one, and emulation. What is the difference between emulation and virtualization? Emulation, what is emulation? And emulation is to emulate hardware by software. So the famous software for emulation is QEMU. I've used Q in order to run software, run software, run some kind of softwares on my Mac OS, because there are instruction set CPU architecture, some types of CPU architecture, and the Mac OS uses ARM architectures. But when I want to use software which uses different architecture, I needed to use emulation. Yeah, so the approach is to make it possible to execute different types of instruction set. So yeah, so there are some types of instruction set CPU architectures. The famous one is ARM and x86. ARM is used in smartphone or latest Mac OS, and x86 is used used everywhere, I think. yeah, and so there are some demand that is to make to execute different types of different types of instruction set. Yeah. I don't. I'm not sure my explanation is good. My explanation makes sense. Making it possible to execute software that uses one type of instruction set on the host OS that uses different type of instruction set, because emulation translate all of instructions, right? So there is large overhead because it needs to translate all of instructions. So compared with executing natively, which is slower than 10 to 100 times. And on the other hand, virtualization is to execute instructions on guest OS natively as much as possible. As much as possible. So when is this exception? That is privileged instructions. Privileged instructions will be executed by hypervisor. So example software as of virtualization are Xen, KVM, VMware ESXi. I don't know what this is. So the advantage of virtualization is less overhead, but there is a condition to use it. We need to make sure CPU architecture, both of guest and host, should be compatible. And the EC2 uses virtualization. So overall, emulation is slow because it translates all of instructions. On the other hand, virtualization doesn't translate all of instructions. It executes instructions on guest OS natively as much as possible. And virtualization separate hardware resources and share it between guest OS which runs on virtualizations, right? Yeah, this is the difference. And the next topic is type of hypervisor. Hypervisor is the software that is used in virtualization, as we saw. And there are two types of hypervisor. Type 1 is also called bare metal type, it doesn't require host OS. It can be executable on hardwares. The example of type 1 hypervisor are Zen and Naitoro. Naitoro is based on KVM. And the type 2 hypervisor, it runs as an application on guest OS. As an example, VirtualBox. So compared with them, type 2 has one additional layer, right? Because it runs as an application on guest OS, so it has overhead compared to type 1, right? Yep. Okay, then let's move on to topic 3. PV, HVM, and PV, HVM. PV is abbreviation. I forgot.
Abbreviation.
Okay, abbreviation. PV stands for para virtualization. Okay. Para virtualization. 準仮想化 in Japanese. Yep. What is it? This is type of software which modify the kernel of guest OS, and it can communicate with hypervisor by hypercode. Modifying kernel of guest OS and communicate hypervisor directly through hypercode. How it works. First, guest OS knows that it runs on the hypervisor. It runs on the virtualization. It runs on virtualization environment. Okay. So, so when guest OS have to execute privilege operation. Know how to execute privilege instructions like IO, page table operations. It requests hypervisor is hypercore. So this type of virtualization doesn't require not to require hardware virtualization acceleration VTX. Hardware 仮想化支援 I don't know how to say it in English. Okay. So memory, how about memory access? Accesses are handled. Let me read. ゲスト OS がテーブルの更新をハイパーバイザーにハイパーコアで通知する。ハイパーバイザーがテーブルハイパーバイザーのオーバーヘッドが大きくなる。Okay. Yeah. Okay. So, yeah, it's not necessary to write down. So, memory access. Memory access obviously requires page table operations. So yeah, so the page table operations are handled by hypervisor, right? Yeah, so I don't need to write down about memory access. It's obvious. Okay, then what happens on EC2? Yeah, this type of virtualization is used in all type of instances. So this is the old type of technology, right? AWS recommends to migrate from PV to HVM. So let's move on to HVM. Abbreviation.
Abbreviation.
HVN is the abbreviation of Hardware Virtual Machine. Hardware Virtual Machine. Let me see. Okay. 하드웨어仮想化支援 Hardware 仮想化支援 is used. Hardware 仮想化支援 What is hardware 仮想化支援 For example, Intel VTX AMD V is used. So this type of virtualization doesn't modify guest OS. Cool. How it works. Guest OS don't need to know that it runs on a virtualization environment. And how to use hypervisor, how to handle privilege instructions. VTX virtualization technology for x86. Virtualization technology. Okay. Virtualization technology extensions of CPU enable to trap privilege instructions on guest OS and then don't need to enable traps privilege instructions on guest OS and then how to say it in English 制御が渡るpass control. Okay, pass control. Passes control to hypervisor. So no hypercall, just trap and pass to control. Pass control to hypervisor. So that's it. And for IO devices, I/O devices is emulated, are emulated. Okay, okay. And do I need to mention about memory access? Okay, okay, okay. I don't know everything, but I feel like the important thing is hardware handles two steps memory address translation. So virtual address on guest OS, which is translated to physical address on guest OS, and then physical address on host OS. Okay. Okay. I'm getting it. So at AWS EC2, the current types of instances are HVM, uses HVM. And it also uses hardware extensions. And for Windows AMI uses HVM because we cannot modify the source code of Windows, because Windows is not open sourced. So yeah, PV is impossible. So Windows also uses HVM. Okay. And what is PVHVM? Para virtualized hardware virtual machine. Based on HVM. But it uses PV driver for I/O. how it works. How it works. So the foundation is HVM. So CPU and memory are virtualized in the same way of HVM. Right? So no need to use hypercore because the virtualization technology VTX extensions can trap privilege instructions and then passes control to hypervisor. So HVM is used for CPU and memory accessing, but the I/O of networking and devices, not devices, storages. It uses PV driver because in HVM mode, I/O devices are emulated, right? So this is the one area to be improved, can be improved. So PV-HVM improved this area, I think. Yeah. So emulation is slower than native execution. So this is the optimal form of HVM, right? HVM doesn't use hypercore, so less overhead, and PV driver doesn't use emulation, so it's faster, right? Okay. So what is required to use PV-HVM? Because the current instance types, all of current instance types are HVM. So what is required to use PV-HVM? It is HVM instances and PV driver. So you need to install PV driver on HVM type of instances, right? Okay, and for example, Amazon Linux AMI installs PV driver by default. Okay. So let's move on to memory access address, memory address handling. Let me see. Okay. We can see the much difference for performance between types of virtualization. So I wanna learn about how it works, where it comes from. So PV, for PV, paravirtualized in paravirtualized guest OS wants to update page table, and hypervisor is requested, and so by hypercore. As we saw in PV type of virtualization, kernel of guest OS is modified, and some types of instructions used hypercore in order to pass control to hypervisor, right? And hypervisor works. Validation and apply. Validates price. Hypervisor return control to guest OS. How it works. And apparently this is slow. So let's take a look at HVM with EPT. What is EPT? Inter-extended page tables is a hardware-assisted virtualization technology that enhances memory management performance in virtual machines by accelerating address translation. Okay. So one of the feature of virtualization technology. Okay, extended page table. Okay, how it works. Guest OS want to update page table. Oh. No, not want to. Guest OS updates page table, and then CPU hardware does 2 steps translation. What is it? GVA. Guest OS virtual address and guest OS physical address, and host OS physical address. This is EPT. So there is no hypervisor in this process. Okay. Okay. Okay, I want to take a break. I learned about foundation of virtualization. What is emulation, what is virtualization, and 3 types of virtualization model, and types of hypervisor, and the about address translation. Okay, in the next video, I'm gonna move on to next topics, more deep. It's about PV driver and enhanced networking. looks interesting. So, but today's broadcast is finished. It's time to finish. Thank you for watching. See you again. See you next time. Bye.